Amar Badal. I'm also on the product team along with Shané.
Hi, I'm Alex. I'm on the product team as well, along with Shané and Ami. Yeah, nice to be here with you all.
Yeah, so if you came to the earlier session, we presented there, and now we're going to do Q&A. Just a couple quick things to note for this session. We are here in person up here, but we also have a few members from the Azure Machine Learning product team also here as well. So if relevant questions come up, we will hand them the mic as well to answer. And we also have some people from the team on the actual call. So we have Vijeta, we have Yisheng, we have Amar, we have Sethu, and a few others like Sakjin on the call as well, that really here to help answer any questions that you have. Oh, and then some additional people like Christian's on the call. Seth isn't here, but maybe he'll pop in. And essentially the way this will work is we're going to have people in person. If you have questions, just raise your hand. We'll run a mic over to you and you could ask your question. And then we'll sort of just like alternate. So you could ask a question. If there's a question in the chat, we'll answer that and we'll go back and forth if there are questions. And yeah, that's kind of it. We are going to answer questions that we discuss or questions on the topics that we discuss during our session. So not everything specific to Azure AI, but we're going to try to scope it to the features that you saw and the capabilities of Azure Machine Learning. Cool, sounds good.
And Shané, from the call, we've got about 60 plus people on the line over here. So folks in chat, if you do have questions as well, feel free to put them in the chat. And then Shané, Ami, Alex, I'll sort of bubble those up as they come along, and we can sort of play some ping pong back and forth where the questions come from. Sound good?
Perfect, perfect. All right, so we could start. Let's start in person. Anyone here has a question? Oh, we'll run the mic to you, don't worry.
Hi, Sean, I'm from MD Anderson Cancer Center. And part of the pipeline that you guys presented today mentioned being able to do hybrid elements of machine learning, right? So on-prem and cloud. How much can you actually accomplish between data training and deployment and monitoring? Can you do on-prem versus in cloud with the Azure ML platform?
Yeah, great question. So you can do both, like training, inferencing, all of that on-prem and on the cloud. We actually have one of our compute experts on the call as well, Vijeta. If you want to unmute and shed some light and more context there. Did you hear the question? We can repeat it as well if needed.
I'm sure. Yeah, I heard the question. So for training, you can use Azure, like Azure Arc, right? So you can bring any on Kubernetes cluster from on-prem, and you can do training on it and also inference. So it is like a first-class citizen for both training and inferencing, like the AK support we have, Kubernetes support we have. So is that the primary question, or do you have more on that?
We'll run back the mic.
Okay.
The mic is coming.
So maybe I'll give a couple of specific examples.
Okay.
If we have data stores that exist both on-prem and on cloud, can we leverage both of those for machine learning, or do we need to move all the on-prem data into cloud before we can do that?
Amar might be a good person to answer that, seeing as data import.
Yeah, I was trying to unmute myself. So it depends on what data store do you have right now? Can I ask that question?
Sure. So we're a medical center. We'll have a variety of different types of structured data storage, SQL databases, on-prem historical data lakes, where we try to do a lot of our original machine learning on premise.
Yeah, I think you can use a combination of our Arc data store and data import. So you can, we support, I will send you the link of what data stores we support through Arc. I think we were supporting SQL, if my memory serves right, Azure SQL. And you have the new option of doing data import, wherein part of data would be moved to your moved to cloud, and we would be importing that data in Parquet format, and we would use it for training. And soon we would be announcing you can set auto delete settings on that, so that the data which you are not using can be deleted, and you don't have to pay for any storage cost. Does that answer your question?
That's helpful. Can I follow up with just one more scenario that we're really interested in, which is we also have a Kubernetes cluster that we built that exists on-prem. We're kind of curious, can we create the training jobs in Azure ML, but actually send the training jobs to our on-premise Kubernetes cluster?
I think we have one other product manager. I will hook him up with you. It is the Arc Kubernetes, and I'll try to. I don't know the complete answer for that question, but I can connect you with.
We have Vijeta here. Vijeta's gonna.
I can take a stab at it.
Vijeta's here.
That you want. It's the same control plane. You could do training, inference, by attaching your Arc cluster. The only prerequisite is you put your plugins there. You got to install your Arc plugins to talk to the cluster. Everything else stays the same. And if you use CLI, you could use the same YAML spec. It becomes a compute that you can attach to.
Thank you.
Thanks for the question.
Yeah, great question. Okay, let's take one from the chat. Okay, I have to scroll. There's quite some discussion.
Yeah,
Okay.
I gotta get one here for you, Shané. Any
Yeah, go
differences
ahead.
between MLOps and LLMOps? And what needs to pay attention to LLMOps versus the regular MLOps? I know Abe isn't here, I don't think, but I'm hoping we can maybe answer that one.
The question was, can you explain the difference between MLOps and LLMOps? Do you want to shed some light on that, Vijeta?
Yeah, great question. Conceptually, all the concepts for MLOps, like sharing and discovering assets, being able to take the model to production, applies to LLM models as well. And now the key here is like taking those concepts and aligning with the new concepts that come in as part of LLM is what we are actively working on. For those of you who you've not used it already, we've got this MLOps V2 accelerator that shows various architectures around MLOps and usage. And we plan to add more such architectures for LLMs as well. So we could use it out of the box.
Awesome. Vijeta, you should just come up here. You're Manage experts. Like, you want to sit? Okay. Okay.
I can add a little bit more to this.
Yeah, sure,
to this
sure,
LLM. So what is specific about the LLM is like, how do we fine tune foundational models? How do you do the deployment easily with all those large models? How do you access the GPUs and optimize using GPUs? Prompt engineering, prompt experimentation, prompt training, and what we call, retrieval augmentation related stuff. So I think those are the specific ones that are being added to this LLMOps considerations. And part of the efforts we are adding here is, I think you already heard about this prompt flow offering, basically to make it easier to deal with the prompt optimization and how to deal with this training. I think those are some of the stories that we are actually considering and offering. So that's
Awesome.
yeah, I wanted to add at that point.
Thank you, Sachin. And we have a question in person.
Yeah, thank you. This gentleman asked a wonderful question, and I see the same problem all over the place. And the way industry seems to be trending is so-called federated learning. In fact, there was a session, just a breakout session in the other room about an hour ago, where it was using OpenFL and NVIDIA Flare as a comparison. And basically the idea is you push the model training to the nodes, and then you send the gradients back to the central server, and you sum them up. That's basically how we do it. Is that idea on the Azure ML roadmap? Because it's a first-class concept. It's well understood. I'm curious if that's a thing. So I'm seeing it, and it's using open source libraries, and it's pretty low level and pretty poorly done. Seeing a managed version in Azure ML would be delightful, and I'm curious if that's like a thing. Is this even on the roadmap? Do people know what I'm asking?
We have someone from our team actually looking like he's ready to answer it. So I'm gonna pass the mic to Manoj, who's a senior PM on our MLOps team.
Yeah. So we collaborated with NVIDIA to launch a preview of the Flare offering. So it's right now in a recipe state. We have built a bunch of interoperability assets that will help you run those assets in a way that Azure Machine Learning understands, like porting those things to the Azure ML jobs structure and like making sure you can trigger them, setting the network parameters so that the different nodes can talk. So it's still in that flare. We are dipping our toes there. But yeah, we see that federated learning is important, and we are going to push more and more on that front. So encourage you to try that out and like start giving us feedback. There's a blog post that you can like go find a lot of details on.
Yeah, my startup's literally based on the idea.
Great.
So you're in the tire kicking phase.
Sort of, yes.
Where you're at, and you're aware of it. NVIDIA Flare, it's a decent implementation.
Yes.
Level. You have some assets and some notebooks and some stuff, and you can kind of plug it in and do some things.
Yes.
Certainly not a managed service.
Yeah.
But potentially could be in the future. You don't know.
Based on the learnings, how it pans out, like we are going to keep learning and exploring. Yeah.
Thanks, Manoj.
Yeah, thank you. Great question. Okay, let's look to the chat. Christian, anything exciting? Or I should just read off what is... See a lot of good questions.
Yeah, good questions. And that federated learning question was a really good question as well. So it seems everybody is picking up on that. So you saw a little bit in the keynote also of our work with Swift that is focusing on that. So it's definitely on our radar there. So I think there is a good question here, more on the data side of the equation here. So what is the data size limit for ML training? Amar, maybe?
Yeah, Amar, you sound like the right person.
I was trying to answer on the chat. Technically, technically the data would be partitioned, and the compute would be accessing this partition data. So you are actually limited by your pool size of your compute. Otherwise, what happens is the training job would run for a longer period of time. So when training runs for a longer period of time, and if you're connecting to a data source which is not in the same network, there are possibilities of failures. So that's where data import comes in handy, wherein even from external data sources like Snowflake or SQL, or even from Amazon S3, you can pull data of your data of interest from your big data set, and then we would cache it in AML platform in a partitioned way, and we would facilitate running training jobs on that, which has more possibility of your training jobs will run more efficiently. Does that answer your question?
Usually, I think Grace asked that question. Maybe a thumbs up so we know if that helped, and if not, you could ask a follow-up so we could address it.
Yeah, that's perfect. I think we have another a couple of questions in the chat about Fabric versus Azure ML, how we're working together with that. Is there anybody that can take sort of just a high overview of where Azure ML and Fabric play nice together, where we dovetail?
Yeah, Amar, back to you. A lot of data questions.
More to come. I'll take that back and then answer.
Okay, awesome. All right, who has questions in person?
So on the question about Fabric and Azure Machine Learning, just wanted to follow up. This is Takuto. I'm Azure Machine Learning Product Marketing Manager. So we're working very closely with my Fabric team and for the positioning of Fabric and Azure Machine Learning. Very high level. Fabric will be more suited for for customers who want to use machine learning as an extension of analytics. So So, when we think about machine learning lifecycle, all the things that are happening before model training or building, for example, feature engineering, data preprocessing, data integration, data unification, those are things that are more suited for Fabric, whereas Azure Machine Learning is more capable of doing machine learning model training, model building, prompt engineering, sometimes with prompt flow, and then also all the way to the MLOps. So that's how we're positioning in very high level, but happy to follow up if you have any further questions.
Thank you, Takuto. Okay, and one more question here. I saw your hand up.
Hopefully a short one. So I wanted to ask a question about the monitoring side of things. Are we able to monitor custom metrics that aren't part of our training data set? So like if we want to measure time speed up when we use a human uses an algorithm, something like that, can we add that to the monitoring dashboards?
Yeah.
So I can answer that. I'll back up. So that's a great question. So the answer is yes, you can. Basically, as part of your monitoring pipeline job, you can bring in a custom component. So we provide components for you that compute things like data drift, prediction drift, data quality, feature attribution drift. But if you want to do your own computations with your training data or with your production inference data, you can bring in your own custom component, define the metric there, and then run the monitoring job as it normally would. And then in terms of visualizing those metrics, that's something we're currently thinking about. I believe that you can visualize them through Azure Monitor today, and then down the line, we're thinking about in the monitoring dashboard we showed earlier, how can you bring those metrics into that dashboard to see everything in the same location? Yeah.
Awesome. Okay, online. How y'all doing? What's next? Let me see.
Chat's filling up. We got 94 people in the room.
Easy.
We just had a follow-up to one earlier question here. If during ML training a cluster has failed, does MLOps have a timestamp to save previous job periodically and automatically to pick up the job from the last save point? So the concept of checkpointing, I think, is a good explanation here. I'm thinking on the training side. I don't see. Is anybody even from the training side?
We have Vijeta from the compute training side, and Ami could also answer some additional training questions. So Vijeta, do you want to start off or add anything to kick us off with respect to checkpointing? And if your job does fail, like anything there that we do on behalf of the user or something that they can configure?
Yep, particularly with like low priority spot training, so checkpointing is the way to recover from it. And I think we have some samples in our repo which we can point to, like how to recover from a failure with a model checkpoint. And the feature we're trying to like do that, like some transparent checkpointing as well, but those are like more feature enhancements. So I can post a link to how to do checkpointing for these kind of scenarios.
Awesome. Thanks, Vijeta. Okay, what else is on the online chat? Let's see. Let me see what this question is. I see a question here around samples. Do we have any pipeline samples that you can use? We definitely have some notebooks available with some sample code and sample examples if you want to get started there. You could also build on that. So that exists. We also have some samples in our documentation. So hopefully that helps answer the question. If not, shoot another message in the chat so I could make sure we answer that question for you. Okay, in-person questions.
So I missed the other session we would have spoke about the feature store stuff. Super happy that managed feature store is coming to Azure. Could someone just give me a bit of insight on to what extent feature versioning is a first-class concept, if at all? Because my life's a nightmare in terms of trying to version data, version train models, and version the code that train the models is a three-dimensional versioning problem for reproducibility reasons. And we do all sorts of insane things.
Yeah.
Like, hashing data and the DVSS, doing all sorts of insane things. To what extent is that like a turnkey experience if I wanted to go back in time over what features were used to train a particular version of a particular model with a particular piece of code?
Yes, versioning is available in Managed Feature Store today. I'm also going to call on Sethu, who's on the call, to deep dive into your question a little bit more. Sethu, you can take it away.
Hey, sure. That's a great question. So let's first talk about the level of support of versioning within Feature Store, and then let's talk about how the lineage part is addressed. So first of all, when you create a feature set, whenever you create a feature set, which is a collection of features, it has to be versioned. So, and it is immutable. So if you want to update a definition of a feature set, because it's immutable, you have to create a new version, right? So whenever you want to change the definition, you have to create a new version. So that is first thing. So in basic, the fundamental concept is it is versioned and immutable. Then the second part of that is that the lineage part. So when you deploy a model that uses a feature set, you will have lineage to say that, hey, this model is using this feature set. And if you go to the feature set, you will see what are all the models that are using this feature set. So there is two-way lineage, and it is versioned again. So it'll point to a particular version. If you go to a version of a model, that will point to a bunch of feature sets, and each feature set can be a different version, right? That's the second thing. And in terms of the third thing is that you would be able to, each of the feature sets that you have the ability to move it across different ML lifecycle stages. So by default, it is development. Then you move it to production, and then you can archive it as well. So you can have an older version archived, for example. And finally, when you deploy a new, let's say you have an old version of the model, and that's pointing to one feature set version. And when you deploy a new version of the model that is using a new feature set, both of them can independently run without affecting SLA of each other. And in terms of the lineage, as I said, within the Azure ML Studio itself, we have lineage as from a feature set to model version and model set to model to feature set version. And if you go to your training jobs, you'll be able to see that is business as usual. What training you run, what is the model that is produced. And I'll post some links here about this, where you can actually see the end-to-end flow of how this works.
Does that help answer your question, or any follow-ups?
Great answer, and it just makes me all very happy. And this is like a bonus question I probably shouldn't be asking. So in GCP, for example, they have a Redis cache abstraction over BQ, and that's how they implement the feature store. I'm just curious if the underlying implementation details could be revealed, or is it like ADLS Gen 2 under there, or just what's sitting under that abstraction? The reason I ask is because I'm curious about Fabric and whether or not it's using the same underlying stuff. Because part of my data estate is going to be building the bottom half of the data pyramid with Fabric, and then the fancy stuff at the top of the pyramid using Azure ML. So I'm trying to figure out if those things are going to converge in the future. There was a previous question that was touching on this, but I'm asking in a more specific way.
Right. So I'm going to share, I'll give you a brief answer. I'm also going to share a pointer to the conceptual architecture and the documentation. And I'm going to put my email as well. So if you have any questions, I'm happy to chat with you offline. But short answer is, currently, Managed Feature Store supports offline feature retrieval, and it is ADLS Gen 2 based. So you plug in ADLS Gen 2 as a materialization store, which is optional, and we store data in Delta table format. And Redis support is coming. It's a part of our roadmap.
Perfect. Thank you.
Yeah. Thank you, Sethu. Okay, I see a question in the online chat that says, how flexible is it to customize the built-in ML models at MLOps? Okay, kind of vague question, but essentially you could customize. I want to know a little bit more about specifically what you mean, but you can build and train your model. So whether you're creating your own model from scratch, you can customize it whichever way you want, adding the features, adding data. It sort of depends on what type of model, open source, OpenAI. Maybe you could share in the chat a little bit more about specifically which model you're thinking about, and we could get into the specifics a little bit. Yeah, but that's just the general answers. They can all be customized. It just kind of depends specifically what you're trying to do, and we could focus in on that question. Christian, anything interesting in the chat?
No, I think you're seeing it. I think the answer, it's a good answer to that question. I think that the concept, I think we see a lot of customers and partners sort of get tripped up on the concept of Azure ML being, like a hub for all these pre-trained models. And that's not necessarily what we are. We're a little bit more of a platform where flexibility is sort of one of the larger value props that we have, right? So being able to lean into the customization of whatever ML model you want to build, that's really, really our sweet spot. And now I think I heard Manoj is in the room. So when it comes to things like registries, when what we announced earlier, I think it was yesterday, the concept of the Hugging Face registry, for example, of being able to take those state-of-the-art models and pull them into an experience in Azure Machine Learning and then be able to fine-tune that. I don't know, Manoj, if there's any sort of color commentary you wanted to give on that as sort of what the extensibility is of that, perhaps?
Yeah, sure. So in the model catalog, I think you're referring to that feature that we recently demoed. You will see like there are two collections. One is the Hugging Face collection, and then there is like the models curated by Azure Machine Learning collection. The goal of the Hugging Face collection is to really serve breadth, like you have tens and thousands of models from Hugging Face Hub. You find a particular model that suits your specific need for inference. You go ahead, deploy that, use that. It's mostly an inference scenario today. But let's say like you really have a very specific domain that you want to work with, like medical, finance, or something like that, and you're not able to find a model that like is out of the box working for you for inference. At that point, we have bought in a good set of base models, foundation models, what you call, and you could take these, bring your data, and fine-tune them. And when you fine-tune in the UI, you're going to find a quick fine-tuning wizard with decent set of parameters and overrides. But if you're really a power user, you would have to go to the notebook samples that are there linked on the model card, and then that will show you how to really like configure every fine-tuning parameter that you are interested in. And beyond that, the third level of configuration is that these fine-tuning pipelines, they are built using building blocks, like one component for tokenization, one component for fine-tuning, another component for evaluation. So you could like go take those building blocks and build your own custom fine-tuning pipelines as well. So that's the idea, like full flexibility to customize depending on the depth that you want to go, but start with a very simple and easy to use experience.
Thank you, Manoj. And you in the chat, I see the follow-up question about fine-tuning that I think was just addressed. So thank you for specifying what you wanted to know with respect to your question. Okay, in-person questions. Who's next? Everyone's a bit quiet. We're only hearing from a few people. Like, what do y'all want to know?
This one relates to a session that just came before this on DevSecOps. Is there integration or interoperability with some of the DevSecOps tools that you guys are creating, like Microsoft Defender, especially when we're moving models from development into production?
Good question. I wasn't familiar with the session that just came before this, so specifically, I don't know what was shared, so I don't want to comment too much on what was shared and how much we support there. Vidya, do you have anything to add with respect to some of the integrations across the different products?
Well, you could tie it in as part of the DevOps workflow, so to speak, to integrate with whatever workflow you want. That is natively supported, but specifically on the DevSecOps, it depends on the scenario that you're looking for. What do you want to do? Like, are you looking for to consume some endpoints that you create that you want to consume there? Specific, probably good to deep dive on that, yeah.
As an example, we're launching a model in production, right? And so we're deploying a container. Are there services like the Defender service that we can look at dependency issues or, right?
Well, that's a good follow-up. So what we could do is, ultimately the way it works is you could literally bring any container. We call this bring your own container. and then hosted as like online or a badge endpoint. That is totally supported today in Azure ML. So I can send you those links. Thanks.
Awesome. I see a question in the chat around, are there some visual tools for model design? And the answer is yes. So we do have a graphical interface within our UI, Studio UI, where you can build your pipeline models. It's drag and drop experience. So if you prefer like UI experience, you can definitely take advantage of that interface and that graphical capability to build and train your models. So the answer is yes. Good question. Any questions in person? Okay, we'll have to take another one from the chat. Christian, any cool questions?
We have somebody asking for a detailed demo for the product, and I'm going to try to link a Microsoft Learn series on that. To be honest, it's a very wide product, right? Some may say it's a platform, in fact, and so it's difficult to really demo one specific area of the product. The product is everything that you're seeing right here that Ami has pulled up on her screen share, and so everything that comes down on the left blade is sort of the various areas or pockets of the product that you can investigate into. But this is our UI, right? This is our take on what the ML Studio should look like. But all this is also accessible via SDK, API, CLI, different ways that you want to be interacting with Azure ML as a product. We want to meet you where you are. So I think that if I can find that right Microsoft Learn tool for you to sort of plug into that, it gives you a little bit more of an overarching understanding of the entire product suite, not just one specific area. And MLOps is a piece of this, right? It's what wraps the entire experience, things like governance, reproducibility, right? But again, that's not necessarily all the product has to offer. So it is unfortunately a tough question to answer, but let me see if I can link a Microsoft Learn area for you there. So yes, yeah.
Thank you, Christian, for that.
Yep.
I see a question in the chat around, are we going to get updated training materials on ML Studio with the new features? Yes. The answer is yes. So the new features that you heard us announce this week, you would start to see blogs, you start to see updated documentation. You'll even start to see for some of these features like updated like samples like in GitHub. So if you want to test it out and try it out, you can definitely do so. So we will have that. And if there's something that you're trying to do and you're not able to, or you don't find the right level of detail in our documentation, please reach out to us. We would love to make sure the documentation is up to date and make sure you are unblocked. So yes, you would see some updated things online.
Yeah,
I'll throw one thing on top of that is that one of our product leaders likes to say that documentation is product. And so we take pride in our docs. There's always room for improvement, but we also take a lot of pride in them. I think our docs team works really hard to make sure those are up and running. But a little known fact is they are based on GitHub. So if you can see anything in the docs you have questions on, you can issue your own PR, but that's really a great place to start to get updated in sort of these new features that are coming out. Shané makes a good point to go to the blog posts as well. So our tech community site will have a number of blog posts that cover all the new feature releases that came out at Build. And pretty much every blog post, I want to say every blog post will have a rich set of links at the bottom of call to action. Here's what you can do. Here's how you can learn more. Here's how you can get this spun up in your environment. So those types of things are all going to be found in those blog posts as well. And Sindura makes a good point in the chat. Hi, Sindura. That these features are also in preview in the preview pane. So Ami, if you can click on the preview pane in the UI, for those of us that are Azure ML users on a day-to-day basis and you want to try out the latest and greatest stuff, Manage Preview Features is your spot for that. I would definitely recommend checking that out as well.
Also, just to add to this preview panel tab, if you're in the product and let's say you're just doing something like you're on one of the pages, sometimes you might see these blue teaching bubbles that might pop up so that it will actually tell you like, hey, this thing is new. in data or new in training, you want to try it out. So you could check that out and learn more when you enable it on this tab. But sometimes that's helpful to also just stay up to date with what we're releasing. So good question there.
Yeah, just like I think Christian and Shané dropped a lot. And just to like summarize.
When we are on this topic, we have GitHub examples repo. I'll paste the link wherein we would have some samples for each of these features.
Thanks, Amar. And I'm going to pass it to Ami.
All good. Yeah, just saying like a lot of the blogs that and the features that we showed in the earlier breakout session and the demos that were public preview are going to be through this preview panel. You can see the build AI solutions, generative models, the experiment tracking tools, the feature store. They're all here. So feel free to check that out. And also a lot of the blogs are already out. There will be more blogs next week with some of these features as well. So keep your eye out for all those articles.
Okay. I see a question here that says, how is the data collected and distributed to be used by analysts after a ML model deployed at real time? So this sounds like a perfect question based on our demo earlier today about model monitoring. So I'll hand that off to Alex.
Thanks for the question. So essentially, this ties back to our model data collector feature, which we announced public preview today. So basically what that feature does is it collects inference data and then logs it to a blob storage of your choice. By default, it's the workspace blob storage attached to your Azure ML workspace, but you can configure it to be a different workspace. And you have the configurability to use an SDK within your scoring script to choose when to log the data. It could be during your pre-processing, it could be just model inputs and model outputs. And then as this data is logged in real time, you can then set up your model monitors to actually see, okay, is the production inference data, is it changing? Is it different from my baseline training data? And that gives you a good sense of, is your model performing well in production from a data science perspective? Let's say you don't have access to ground truth, you can monitor your model using various data drift metrics, prediction drift, data quality metrics, and yeah, we provided all of that as part of our release today with model monitoring.
Thank you, Alex. Okay, in person. Anyone has any questions? Excited to hand you over the mic. Just has your name written all over it.
We promise we don't bite.
Who here has used Azure Machine Learning before? Okay. 1, 2, 3. Okay, so 2 out of the 3 people who have used it before, the ones asking questions. Okay, that makes sense. Excited to see so many of you who haven't tried it yet and here to learn more. Do you have any questions as new people about to try Azure Machine Learning? Any questions that you think might come up and you want to get ahead of them before you get started?
Yeah, I just have a very basic question. So we have been using like Azure Databricks for our data lakehouse and machine learning capabilities out there, and very interested about the Azure AI Studio and Azure Machine Learning, especially around the integration with large language models, which I think is something that is natively working with Azure, OpenAI, which is awesome. And just curious, like. How do you see the Azure ML versus the Databricks, and how do they, work together when you use what, and what would you see if any customers using like both together or like one versus the other?
I might be able to take that one, Shané.
Yeah, go ahead.
Yeah, so it's a great question. So the Azure response is wherever you want to do your work, you should do your work. We tend to think about machine learning within Azure ML as sort of distinct from data prep and data analysis, and also distinct from visualization, sort of on like that supply chain of data to insight, right? We envision Databricks as sort of like that big pre-processing step, right? Making sure that the data is in a consumable fashion, and of course, like you pull that into Azure ML, you want to, take a couple parquets, CSVs, you want to use pandas and make your data frame, constructed in the way you're looking for. That's definitely the sort of the central wheelhouse of Azure Machine Learning. But where Databricks fits in is sort of like that large scale ETL, We want to be able to do the sort of data munging and then exploratory data analysis. That's where we really see that come into play. I know there are some folks that, some customers that do use it for machine learning, and that's fantastic. We like our product, and it's probably because that's what's on the top left of our paychecks every 2 weeks. But when it comes to things like distributed training, when you get to GPU-based ML training, like that's really where we tend to perform extremely well. So it depends on your task, I think. It depends on your task, your comfort level, where you like to do your work. For example, if you work primarily in VS Code, we want to meet you where you are for Azure Machine Learning, and we don't want to change anything that you are working on, already. So I think open and interoperability is sort of where we would like to play with that. There's no right or wrong answer. It's just a matter of preference, to be honest.
Here's another perspective. I'm Seth. I work on the Azure ML team.
Hi, Seth.
Hi. This is my team. They're so nice. Here's another perspective. Azure Databricks is awesome. If you are a data engineer that's trying to get an understanding of data and doing analytics, it's amazing. And machine learning for analytics is a very different proposition than machine learning for putting it into software. Because as you know, the end result of an analytics job is a graph, a chart, or a report, which is super important because you make business decisions. But if that's the end result of your machine learning, then Azure Databricks is a fabulous answer. But if you've ever done machine learning and you've tried to operationalize it, notebooks have like this hard edge to make it repeatable. You know what I'm saying? Ever tried checking one of those things in and then getting it out and then getting conflicts? So notebooks have a hard edge when it comes to repeatability. Azure Machine Learning is designed for putting machine learning models into production for use in software, which is different. It's a different proposition. And so you may discover that there is an automation that you do in Azure Databricks, which yields a really good report that you find now wants people, the bosses want them integrated into the software so that you see it in the software. If you're using a notebooks-based platform to do machine learning, that's going to fall over when it comes to MLOps, unfortunately. And it's just, if you've ever, anyone that's used notebooks in here, they're great for exploration. They're great for data science. They're not so great for repeatability and reliability. You have to get the stuff out of there into a script or something that then's automated and tested. And that's where Azure Machine Learning really stands out. And the reason why it stands out is not because we think it's awesome, but it's because all of Microsoft uses it, including OpenAI. So if you're wondering, when should I use which? If you're using machine learning for analysis and reporting, Azure Databricks is awesome. If you need to put your software into production, then Azure Machine Learning, I think, is better. And that's because I'm biased, but also because it's true. Does that help?
Cool. Thank you, Seth, for joining and sharing that. Okay, we have 2 minutes left. And this is your time to get your final burning questions out. So I see one hand raised. See, like when there's a time crunch, we get more questions from the ones that are quiet. Okay, go on.
I was just wondering, do you have any recommendations for best practices to scale the usage of Azure ML across teams, right, in terms of MLOps?
Oh, good question. Oh, I see Manoj has his hand up. Let me hand it off to you. I have some thoughts here too. Yeah.
You can go first.
Now I lost my thoughts.
Yeah. So last fall, we shipped this feature called Machine Learning Registries, and we announced general availability like this week. Basically, the machine learning workspace maps to one project or one team. And what we realized is that as you kind of grow and there are like more teams working on machine learning in an organization, inevitably you tend to kind of share assets across these teams, or maybe there might be infra teams that are building the platform assets, or you might have a scenario where you are developing something in a dev workspace, but then it has to be put into a production workspace in a different subscription that has like a different billing or different level of security. So the concept of a machine learning registry is that once you develop something in a workspace, you can promote that from the workspace in which you developed it into the registry, and then like pull it into the production workspace from that registry. So that's the glue that acts as a sharing platform within your organization. We are also using it to build and ship all these foundation model assets, like the foundation models and the components and pipelines to fine tune these. All of these are coming through what we call as a system registry, which we have created within the Microsoft organization, and we have opened it up to all Azure Machine Learning users. So it's built on the same infrastructure.
Yeah, great answer. And also to add to that, I think with a growing organization and one that's scaling, you could also take a look at the managed feature store that was talked about earlier. You know, to version those features, make sure users are using the right version of it, like you're not sending it over email. So you could use a lot of these features in, you know, conjunction to make sure you grow and scale accordingly, and also within the compliance of your organization. It's a good question. Okay, we are at...
Shané, can I add one thing there? In the AI Studio, we have the concept of the project, and we have also team settings there. So essentially, in the future, all the team settings will have all your shared resource across projects hosted there. So that will scale out to one team for projects, many projects very quickly there. So that's in our plan there.
Yeah, thanks, Yisheng, for adding that. And just like that, we're at time, 6:01. So thank you, everyone in person and online who joined to ask questions, chime in. If we didn't answer anything and you still have questions, reach out to us, and we'll be happy to answer it. So thank you all. See you next time.
Thank you.